Find the Laurent series centered at the origin for the given function. Part A, sine z over z. Part B, cosine z over z. Part C, e to the z over z squared. And part D, 1 over z to the fourth. I'm going to start with part D because I can't resist. This is its own Laurent series. It's a single term, but this is its Laurent series because the Laurent series looks like summation k from negative infinity to infinity, c sub k, z to the k, and this is, we can put it in this form if we want to do k equals -4 to -4 because it's just one term. C sub -4 will be just 1. And then we have z to the k. The other coefficients are all 0. Okay, so let's look at these more complicated ones here. Sine z over z. What we're going to do is use the Maclaurin series for the function in the numerator in all three of these cases, and then perform the division. So sine z over z, that's 1 over z times sine z. The Maclaurin series for sine z is z minus z cubed over 3 factorial plus z to the 5th over 5 factorial minus z to the 7 over 7 factorial, etc. Multiplying by 1 over z gives 1 minus z squared over 3 factorial plus z to the 4th over 5 factorial minus z to the 6th over 7 factorial, etc. And we notice that there are no negative powers of z here. The smallest power we have is z to the 0, so this is actually not only a Laurent series, but it's also a Maclaurin series. The function sine z over z is technically not defined at 0, but we can see that sine z over z has a Maclaurin series that converges when z is 0 to just 1. So this function has a removable discontinuity at z equals 0, and if we define the function to equal 1 at z equals 0, then it would be analytic. It would be an entire function with this Maclaurin series. Now for the cosine z over z, that's 1 over z times, and here we'll put the cosine series instead of the sine series. The cosine series is 1 minus z squared over 2 factorial plus z to the 4th over 4 factorial minus z to the 6 over 6 factorial plus, etc. Multiplying by 1 over z, we get 1 over z times minus z over 2 factorial plus z cubed over 4 factorial minus z to the 5th over 6 factorial, etc. So here, this is not an ordinary Maclaurin series because we do have a negative power of z. Here is z to the -1. So this is a Laurent series. The Laurent series centered at the origin means that we have, instead of z minus z0 to the k, it's just z to the k because z0 is 0. That's what it means to center at the origin. I don't think I mentioned that. And finally, we'll look at e to the z over z squared. That's 1 over z squared times the Maclaurin series for e to the z is 1 plus z squared over 2 factorial plus z cubed over 3 factorial, etc. So if we multiply by 1 over z squared, we get 1 over z squared plus 1 over z plus 1 over 2 factorial plus z over 3 factorial plus z squared over 4 factorial, etc. So we have two terms that involve negative powers of z. We have z to the negative 2, and we have z to the negative 1.